Long division is all about following a series of steps and repeating that series over and over again. In this problem, we have this long polynomial divided by x plus 6. So to start off, we want to set this up with our long division bar. That x plus 6 goes on the outside, and this long polynomial goes underneath the bar. So we have x to the third plus 4x squared minus 9x plus 18. All right, now for our first step, we always want to look at the leading terms. So on the outside, our leading term is x, and on the inside, our leading term is x to the third power, x cubed. What we want to ask ourselves is this first leading term x times what equals this leading term x cubed? So x times what equals x cubed? Well, x times x squared equals x cubed. So now that we've figured that out, we write the x squared above the bar. Okay, so now we're on to step 2, which is to multiply. So now we're going to take that same x squared and multiply it by this x plus 6. Now keep in mind, you have to distribute. So we have x squared times x, and we have x squared times 6. So x squared times x is going to give us x to the third, and x squared times 6 is going to give us 6x squared. And we write those down below. Notice we're lining up our x cubes and our x squareds. Okay, next up we have the subtraction step. So I'm going to draw a bar underneath and a subtraction sign, and I'm going to subtract down like this. So x cubed minus x cubed, well, that equals 0. They cancel each other out. So I could write 0, but I'm not going to. I'm just going to cross them off. Next, we're going to subtract these guys. Now, if you think the answer is 10x squared, I'm sorry, but you're wrong. This is a really common mistake. People just see the plus here and they think they should add. They forget that there is this subtraction sign out in front. This is really 4x squared minus 6x squared, which equals negative 2x squared. So be careful there. Next, we're on to step 4, which is to bring down just the next term in that original polynomial. So minus 9x, like that. And so we have completed our first cycle, and now we're going to start all over again. We're once again looking at our leading terms. So our leading term up here is still x, but now our leading term is negative 2x squared. So we're still asking x times what, but now it's x times what equals negative 2x squared. Well, x times negative 2x equals negative 2x squared. So we've got that negative 2x. We're going to write that above the bar. Now we're again on to step 2, which is to multiply, and don't forget to distribute. So now we're taking that same negative 2x and multiplying it times the x and times the 6. So negative 2x times x gives us negative 2x to the third. And negative 2x times 6 gives us negative 18x, negative 12x. Okay, so notice that these guys match, but these guys don't. That's okay. All that you need to match is these first 2 terms. The second 2 terms probably won't match, and that's what we expect. Okay, so next up is our subtracting step. So I'm going to draw the little bar. I'm going to write my subtraction sign. I know these guys, when they subtract, they cancel out. And here, again, if you are getting negative 21x, you're doing it wrong. Here, we want to read this as negative 9x minus negative 12x. I'm going to write that out. Negative 9x minus negative 12x. What happens when we have a minus negative? It changes to a plus. So this actually comes out to 3x. Last step, bring down the 18, and we start our process all over again once more. Again, we're looking at our leading terms of x and 3x now, and we're asking ourselves, x times what equals 3x this time? Well, x times 3 equals 3x. So we'll put a 3 there, and because it's a positive, we're going to put a plus in front of the 3. Next, we multiply, so we're multiplying that 3 times the x, and of course, we're distributing 3 times the 6 as well. So 3 times x is 3x, and 3 times the 6 is 18. Oh, hey. All right, next up, we've got to subtract 3x minus 3x, those cancel out, and this time we have 18 minus 18, which equals 0. Now you're going to see this a lot. This means the fact that we got a 0, first off, this means we're done. And it also means that we have no remainder. If this was some number other than 0, it would mean that we have a remainder, and we'll talk about that later. But when you get down to 0, it means you're done. Now, what's our answer? Our answer is all of this in red. X squared minus 2x plus 3. So we could finish out our little division problem here. This whole polynomial divided by x plus 6 equals x squared minus 2x plus 3. That's it. As long as you follow those 4 steps over and over again, you'll be just fine. Now, you can also check your answer. To check your answer, you just multiply you multiply your answer times the thing that you were originally dividing by. In this problem, we were dividing by x plus 6. So we're going to multiply our answer times x plus 6. I'll just multiply this out real quick so you can see how to check your work. So remember to distribute. So we have x distributed to the x squared, that's x to the third, x times x times negative 2x is negative 2x squared, x times 3 is 3x, and then also distribute this 6 times x squared, 6x squared, 6 times negative 2x is negative 12x, 6 times 3 is 18. Now, this doesn't look like what we started with, but that's because we have to combine our like terms. So we have like terms here and here. We have like terms here and here. So I'm going to combine everything to get x to the third plus 4x squared minus 9x plus 18. And if we did everything right, then this should match the original polynomial in our problem. We'll do one more example and end with a few pointers. So here's our problem, and of course we want to start by setting up the problem with our division bar. So here it all is. Now remember, our first step is to look at the leading terms. So we have the x as our one leading term, and 3x to the third is the other leading term. And we're asking ourselves, x times what equals 3x to the third? Well, in this case, x times 3x squared equals 3x to the third. So now we're on to step 2, which is to multiply. So we're going to multiply that 3x squared times the x and times the negative 4, and that's going to give us 3x to the third, right? Because that x squared times another x makes it x to the third. And then here we have 3x squared times negative 4 gives us negative 12x squared. Next, we subtract. So I'm going to draw my bar and my subtraction symbol. These guys we know will cancel out. And now here, think to yourself about what this equals for a second. If you said negative 21x squared, you're doing it wrong. Don't forget about that subtraction sign out in front. This is really like negative 7x squared minus negative 12x squared. That minus negative basically changes to a plus. So this turns into positive 5x squared. Next up, we bring down our next term, so bring down the negative 21x, and we start all over again looking at our leading terms. So we have a leading term of x and a leading term of 5x squared. Now we're asking ourselves, x times what equals that 5x squared? Well, x times 5x equals 5x squared. So, and put a plus in front of it if it's positive. Step 2, we multiply, so we're taking that same 5x and multiplying it times the x minus 4. 5x times x is 5x squared. 5x times negative 4 is negative 20x. Next up, subtract. These guys cancel, and we have negative 21x minus negative 20x. This is going to come out to, that's right, negative 1x, or just a negative x. And last but not least, bring down the plus 4. One more time, we're going to do our leading terms of x times what equals our new leading term of negative 1x. Well, x times what is negative x? Well, times negative 1, right? So we'll write that negative 1 up above. We're going to multiply it out. Negative 1 times x is negative x, or negative 1x. And negative 1 times negative 4 is a positive 4, right? Because a negative times a negative is a positive. Next, we'll draw our subtraction bar, write our little minus sign. These guys will cancel out. 4 minus 4 comes out to 0. And we're done. When we get to 0 with nothing else left to bring down, our problem is done and we know our answer. In this case, our final answer is all of this, 3x squared plus 5x minus 1. A few pointers to watch out for. First off, here's a problem. Let's try setting this up. You might be tempted to set this up the same way we've been. With the little division bar, you put the polynomial underneath, x to the third minus 2x plus 1. You're going to put the x plus 5 on the outside. If you set this problem up like this, you're going to run into problems. Look carefully at the exponents on that original polynomial. Do you notice one is missing? Yeah, there's no x squared. That would normally go in between the x to the third and the negative 2x. If the polynomial is missing any of the exponents going down from 3, 2, 1, 0, you have to still write them in when you set it up with the division bar. So here's what that would look like. X to the third, we got that. Next should come x squared, but there is no x squared here. So what do? We put a 0 x squared in our setup. All right, next would be just a plain old x. We do have that, so now we'll write minus 2x. All right, we got that. And then next comes our constant, which is just a plain number, plus 1. We got that. This is how you should set up a problem, even when you're missing some of your exponents. So always really pay attention to that. The last thing is about remainders. So here's a problem where you have a remainder of some number other than 0, right? So we've gotten to our end. There's nothing more for us to bring down, but rather than subtracting here and getting 0, we got this number of negative 114. Here's how you would write your final answer. Once again, we're taking the stuff that we have up top, that's here, and then you're taking that remainder and putting it over the thing that's on the outside, the thing that we were originally dividing by. So this is how you write your remainder if you have one. Guys, I made a tiny mistake on that first problem, and that mistake happened right here. It should have read negative 2x squared, not negative 2x to the third. And that came from when we did this negative 2x times this x. When you multiply those, that x times x gives you x squared, not x to the third. This is what I meant to say, but I accidentally said and wrote to the third instead of to the second power. Everything else is still correct. So now you can see that negative 2x squared canceling out with this negative 2x squared. The rest of the problem is correct. Guys, this is just part of doing math. Sometimes you make those tiny little mistakes, and as long as you can go back and check your work and find them, it's a big part of the learning process. So happy long dividing, and we'll see you in the next one.